if you have this view of the world that the physical sciences are the way to get truth, this narrow view of the sciences, then, like many people say, you can ask the question, or you can say to someone, okay, well, now prove to me that God exists. As a kind of, almost as a jab to say, well, God doesn't exist because I can't prove him scientifically. I can't, through the physical sciences, through experimentation, through measurement, I can't prove that God exists. Therefore, I'm just going to say that God doesn't exist.
3, 2, 1. Welcome to Love Machine.
Welcome back to another Nerding Out with That Nerdy Catholic. I'm here again with my co-nerd, Cesar, and we are continuing our exploration of the history of math. And I just want to remind you that this is just a small part of the bigger discussion that we really want to have of this question of what is math. And well, before we get into that, I want to remind you that we're really glad that you're here. If this series has had value to you, we would love it if you would subscribe to this channel, share these videos with your friends, your family. We really want them to be part of a bigger discussion. As I was saying, this question of what is math is really a part of a bigger question of what is truth. And as Catholics and as nerds, we want to understand all truth. We want to be able to understand mathematical truth, scientific truth, as well as theological truth about God. And I think it's an important discussion to have, especially this day when it is so easy to see people that are talking about such a narrow view of truth. Whether there's religious people out there that are saying have very dogmatic, narrow view of what truth is, and other people that say, well, no, it's science is what's true, right?
And on the other hand, we know from scriptures that the heaven and the earth glorifies their creator.
Yeah.
So we strongly believe that in going in a true pursuit with open heart on math and on science should point us to our creator. No?
Yeah. Well, and before we jump in, I just want to remind you that we have our merch now. You can go to Nerdy Catholic, thatnerdycatholic.com/merch, and get mugs, t-shirts, got That Nerdy Catholic and Nerding Out merch, and anything that you purchase on there helps support our show, helps us do the things that we need to do, pay for hosting and things like that. So anything you can do to help out is greatly appreciated. But yes, so I love that's a great kind of segue into our discussion today. The heavens declare the glory of God, and it's not just a theological looking of the heavens, thinking about God living in heaven. But I think it's really interesting that if you look at the Hebrew word for the heavens, it's plural.
Yeah.
There are multiple heavens, and the Jewish concept of the heavens was anything above us. And so you have the different levels of the heavens, the sky, the stars, everything that's up there, up in the heavens, and then above that is considered the heavens where God dwells. But it's not just heaven where God dwells that gives glory to God.
Yeah.
It's the heavens. And so the first mathematician that we're going to be talking about today, Blaise Pascal, he's a great example of someone that studied and desired to know all truth.
Yes.
And his study of the heavens, including astronomy, really was so that he could give glory to God.
And that's true. Blaise Pascal, he was a French mathematician and physicist, and actually a genius, I would say.
Mm-hmm.
So he was born in 1623, and when we talk about Pascal, we are talking right now about modern math. No?
Mm-hmm.
So
Yeah.
he separates 60 years from Galileo Galilei. This is all already modern math. This is where some modern concepts start beginning. But also, as you mentioned, this is the time that some of the let's call it university professors are asking the question: Is science sufficient? Do we need a God besides science? No. So Pascal, he was really Catholic devotional. Let's put it in context first. He has many contributions in math. No, so for example, we have the triangle of Pascal, who the ones who knows math, that is very important to start developing the Newton's binomial. He started grasping the idea of having the concept of mathematical induction. No? So and this is what mathematical induction says. No? If I prove the initial condition, and I can prove that from any n condition afterwards we can derive n plus 1, then we have proven the whole concept.
Okay.
So but the philosophy behind this is that if you prove that there's the initial condition is true, and then from one condition you can derive the immediately next one, that means that you can prove, first of all, it also is implying that you expect that order in any place. No, that is not going to be changed. No. And the second thing, it allows you the first grasp on infinity. No? So mathematical induction is and for many who are mathematicians, that is a very important topic to talk about when proving things. No? Especially when proving series that goes into infinity, which is we are going to see a lot in modern math now. No? We'll have probably a discussion on what different kind of infinity we will have. No,
we'll have an
yes,
hopefully not an infinite discussion.
Hopefully not
on infinity. Yeah.
With that, his contribution is not only in math but also in physics. No, he studied the first principle of hydrostatic, hydrodynamic. No, and he defended the scientific method, which is another important thing. No? The scientific method. What does the scientific method say? Because when we talk about science, and I always hear that I believe in science. What does it mean?
What do you believe in when you say I believe in science? Yeah.
Because what science is, it's a way to understand nature, not to create, but to understand. No, and the scientific methods start observation, the hypothesis. Then you want to make a statement that has to be proved. Then you do the experimentation. Then you get the results and the publication part. No?
Well, and I think an important thing to understand when you're talking about science is what does the word science mean? It means knowledge.
Yep.
So the scientific method is a way of gaining knowledge.
Exactly. Getting knowledge. When somebody says, I believe in science, they are saying implicitly, I believe what this author is saying, but that is not necessarily science, because it's just believing in somebody. You know what I mean?
Or even saying, I believe in this specific set of facts,
Exactly.
which is also not science.
Exactly.
They're scientific facts, but it's not science.
Science is only when you can prove either with your intellect or when you can prove something about nature with the scientific method. We have to understand that that there is a way to pursue truth, and that makes us think about what have we, the way we have learned in school, and sometimes it's just memorizing things. It's not per se science.
So what were some of the other contributions that Pascal had?
We have very important contributions on math and physics, but there is a part that that we want to stop discussing, which is what he think about his faith. And he was a very Catholic devout person. So let's examine what does he say about that. I like to start with one of the quotes here. Physical science will not console me for the ignorance of morality in the time of affliction, but the science of ethics will always console me for the ignorance of the physical science.
Yeah, I love that quote because for a couple of reasons. One, it uses the phrase "the science of ethics."
Yes.
And one of the issues with our current, with many people's current understanding of science, like you're saying, when someone says, "I believe in science," many times they're saying, "I believe in some certain scientific theories." They say, "I believe in evolution," right? But the current, what I would say most people understand when they say the word science is limited to the physical sciences. And when when I read Pascal saying the science of ethics, realizing that in his it's a classical view of the sciences, which is any pursuit of knowledge. So you can say the theological sciences, the ethical sciences, the philosophical sciences. Any pursuit of knowledge is considered a science.
Yes.
And it's not just our modern worldview of science only pertains to something that you can see,
materialistic.
Yes. You can see, you can touch, or you can measure. It's a very narrow view of science.
And for the ones that disagree and that say science is only for about the physical world, let's talk about knowledge then. And he put two kinds of knowledge, one above the other. So we have the physical knowledge here, but he puts the ethics above the physical knowledge. So and that is a very important distinction. I'm going back to Plato's cave. For the one that haven't seen that episode, I recommend you to see that episode.
It's episode number 1.
There is in Plato's cave, when you are remember the man in the cave looking at the shadows, that's only when you see nature and you don't ask further question about that, But you have to liberate yourself to be able to go outside to see the truth, And we were discussing a lot, that the physical world versus the ideal world. And remember when we were discussing the physical world, all the elements rust, deteriorate, doesn't last forever. On the other hand, the world of the ideas lasts forever, doesn't change, is immutable, is not corruptible. So what kind of knowledge is better than the other? And if you think about that, there you go. Blaise Pascal just nailed it, The one that doesn't change, that one that holds true forever, the one that is not corrupt, is above the other one.
Yeah. So that quote is from his book Penses, and he never actually finished it. It was his last work, and it's published in its draft state. I mean, there's a lot in there, and I will admit that I have not read the whole thing. And so it is an even greater goal of mine now to go back and read the whole thing. It's his thoughts on the world, on truth, and he talks a lot about what he's learned in math, but he puts it in the context, like he says here. He puts it in its correct context. He looks at the limits of what we can understand through science, what we can understand through math, and that's especially important to hear from someone who thought that math and science was so important.
Yes.
If you there are people that talk about that kind of thing. People that talk about, it's like, well, math and science aren't as important as studying religion or studying philosophy. But many of those people aren't mathematicians or scientists. And so you can hear what they say and say, well, wait a second. They're saying that math isn't as important because they don't really understand the math.
Yeah.
They're saying that science isn't as important because they don't really understand the science. Which is why I really appreciate hearing that from Pascal, because he did understand the math. And he did understand the science, and we have a greater understanding of math and science because of him, because of what he did. I mean, he really pushed the math and the science to a greater understanding, and yet still at the end of his life could say, but still there's a greater knowledge than that.
That's true. And there's a quote here that it says, too much truth is paralyzing. I know some who cannot understand that take 4 from nothing leaves nothing. So, of course, a mathematician will say 0 minus 4 is minus 4.
Yeah, -4, yeah.
-4, yeah. But in a situation when you don't have nothing and you want to take somebody 4 apples from that person.
Yeah.
Still got nothing.
Yeah, I don't have any apples. You say, give me 4 apples. Well, okay, well, I still have no apples.
Yes.
Yeah. It's easy to get so wrapped up in finding the truth in math that you're saying that you lose, you lose the ability to kind of see the everyday uses of math.
Exactly.
Right? Someone can get so focused on certain theories in math and say, but that math becomes everything. That then they think about the everyday life. It's like, well, yeah, if I have 0 apples and you ask for 4 apples, well, then I have -4 apples. Well, but what is -4 apples?
Exactly. And one of the things that we have to remember is math per se is an instrument to discover truth. It's not it's not the end goal. No. So when somebody treats math as the end goal, that's when I think these things happens. No?
Yeah.
Is the utilization of math in a certain concept to pursue truth that when really math helps. No? So I think that's a very important thing to remember.
And also thinking about how then we look for all truth, to say, well, how do we look for truth? How do we discover truth? And if you have this view of the world that the physical sciences are the way to get truth, this narrow view of the sciences, then, like many people say, you can ask the question, or you can say to someone, okay, well, now prove to me that God exists. As a kind of, almost as a jab to say, well, God doesn't exist because I can't prove him scientifically. I can't, through the physical sciences, through experimentation, through measurement, I can't prove that God exists. Therefore, I'm just going to say that God doesn't exist.
Yeah.
Where when you take a greater view of the sciences, as a pursuit of truth, then you're going to say, well, let's look at the different types of truth and how we can arrive at them, right?
Now that you're saying that, I remember the film, the movie Contact, where Matthew McConaughey asked him,
Yep.
I don't believe in God. Okay, yeah, no, but and they were talking about the dad of.
Yep. He said, he says, well, does your dad love you? And she said, well, of course he did.
I don't know. I couldn't imagine living in a world where God didn't exist. No. I wouldn't want to.
How do you know you're not deluding yourself? I mean, for me, I'd need proof.
Proof. Did you love your father?
What?
Your dad, did you love him?
Yes, very much.
Prove it.
He goes, prove
it.
Yeah.
There you go. So there's an
And,
example of a reality that cannot be proved with science. I love that quote.
Yeah. Well, and so that leads us then to what I think most people know Pascal for, is Pascal's wager.
Yes.
And if you have a very narrow view of the sciences, Pascal's wager feels very odd. That he says, all things being equal, it is better to believe in God than to not believe in God. And it is it's not a basis for faith. It is a first argument to say, well, you know what? Why don't you just give God a chance? As you said, the period of history that Pascal was living in was the beginning of, almost you can say the seed of where we are right now.
Yeah.
The modern era.
Yes.
And as you said, there are people that were just starting to ask the question, well, we now have this greater scientific understanding of the world. Do we even need God? And this view of God as a, the phrase, and I can't remember who said this. I feel like it might have been C.S. Lewis, the God of the gaps.
Yeah.
That, if there's something you don't understand, well, then God did it, right? And as soon as we can understand it, well, then we can get rid of our need for God there.
Yeah. And that's a very narrow vision of God.
Yeah.
But that's another whole statement to see, and the last quote of Pascal, we have to understand that he was trying to answer the question of some of their colleagues as saying, I don't believe in God. There is proof. There's no proof that God exists, but either there's no proof that God doesn't exist. So under this understanding, this statement, he's again putting what it's better for you, but trying to reach people that has not faith. Please understand, they said, no. Even when you consider that there's a note that there's no proof for the understanding of God, then if you don't believe, it's better to believe because it has a deeper meaning that just ending these things like it is. It's a good starting point if you don't have faith to start asking the questions.
Yeah. If God exists, and if God exists as we understand, as Christians understand him, that he is there, and he is, that God is above the world, but God is also in the world. God is involved in the world, and as it says in the Psalms, seek God, and he will be found.
Yes.
That God isn't. It's not the as in this period, the beginning of a lot of the deist view of God.
Mhm.
where he just kind of winds up the clock of the universe and lets it go
Mhm.
and just kind of stands back. We believe that God is involved in the world, and so if you seek him, you're going to find him, and if you ask, he will answer he will help you find the answers to your questions. Maybe not the way you expect them,
Yes.
but there's ways of finding knowledge of God.
That's true.
So
Talking about knowledge of God, I think it's time to go to the next one, which is Isaac Newton.
mm-hmm.
And what I love is like Isaac Newton is very well known. No? He invented calculus, and although there's a dispute among Leibniz and Newton who invented calculus first, but at the end, I think we can all agree that they both invented calculus in the same way. Although Leibniz was on the integral calculus while Newton on the derivative calculus, but they both invented calculus kind of simultaneously. We are talking about Newton here. We are talking about 1727. He was born in 1727. And of course, he is one of the, I would say, the figure of modern era math and physics. No, there's his book, and I would like to stop talking about the title of his most famous book, which is Philosophiae Naturalis Principia Mathematica. That's Latin, no? So that's mathematical principles of natural philosophy. He didn't say science. He said mathematical principles of natural philosophy.
Yeah.
So he acknowledged that philosophy, which means so the exact name, the exact translation of philosophy is love of wisdom. That's philosophy. That is love of wisdom. That's. And then, so it's mathematical principles of natural philosophy. So we love wisdom. We are just going to talk about the whole wisdom. We are going to talk about the natural world.
Yeah.
And to understand this natural world, we are going to put these mathematical principles.
Yeah.
So
yeah. Well, and I think we've talked about before about science. That science is knowledge, and I think it's an interesting connection between science and philosophy. You have knowledge and you have wisdom, right? And knowledge, what you can understand, what you can learn, whether it's facts or concepts, you gain knowledge. But wisdom is how you take that knowledge and apply it to your life, you apply it to the world. And so I like that the focus of natural philosophy is how can we take the science, what we learn in facts and concepts, and how do we apply that?
Yes.
What does that actually mean in trying to take that science and bring it to philosophy, and that it's natural philosophy.
Exactly.
Yeah.
Exactly. And this is the Newton that says, I'm marveling about, he didn't say, oh, there's a law of gravity, there is no God. He said, what a marvelous God that has written the whole universe in these simple mathematics. So he takes another view, no? And the other thing, although by 1969, when we put the first man on the moon, there was Einstein equations, the computer in the that take us to the moon, it follows Newton's principle. It doesn't, because that was a hell of a math that Einstein did, no? So but it was Newton's law. Even today, it's very well used because of how simple to apply to our case, not to what's happening now, to our context. No?
Yeah, that view of the universe, looking through the science that we've learned. One of the things that I think that's important to see is that, Pascal, Newton, these were devout Catholics that they saw the world, but they wanted to understand how the world worked. They wanted to understand the science behind the world, the math behind the world. But when they saw that, as you just said, they saw the order through the science, and they saw a world that was understandable.
Yep.
One of the things, looking all the way back at the ancient world when we were talking about it, is that the ancient world, you look at the Sumerians, the Egyptians, what we would say now the pagan world. There was an understanding of the world that you had gods that were in charge of everything, and whatever the gods decided, that's what happened.
Yeah.
And so there wasn't order.
Yes.
It was chaotic.
Yes.
Because it came down to the whims of the gods.
Yes. And
it's because of the Judeo-Christian worldview that when you had the Jewish nation, when you had the Israel talking about their God above all gods, that they were talking about a God of order.
Yes.
And a God that created everything, and everything exists and everything is ordered because God created it.
Yes.
And so because you have a God of order, one God above everything, then you can have a universe that is understandable, because it's not up to just every whim, but we can study the universe. And so the sciences exist because we believe that the universe is ordered. Exactly. And you have so many scientists throughout the last hundreds of years that studied the universe, that studied science, that studied math, because they believed that there was order and it could be understood.
Yes. Even the atheist scientists believe and have to act of faith that there is an order that has to be discovered. Yeah. You're totally right on that. Yeah. No. So just a little point of clarification. Newton was he was a Christian mathematician. He wasn't
Catholic.
Yeah, he wasn't. By that time, Henry VIII has made the conversion for England.
Right.
And but yeah, we got so many contributions about Newton here. We got the law of motion with 3 law of motions. We know that, no? The universal gravitation. That's Newton is famous because of this, no? And but then we got also many contributions in math, because of course he's famous on the physical on the contribution of physics, but he made a lot of contribution of math, and even during my high school I was amazed. This guy must be a really genius. He made contribution on the calculus, no? So, and with calculus we couldn't afford to understand furthermore this world, no? How to shape volumes, integration, derivation, changes of speed, acceleration in a precise instant. That's all calculus now. So our current world goes around because of the system of calculus now. And then we got optics, and I remember when I was a kid, I Newton's disc, you got the different colors, and then you start rotating those colors, and wow, you got white. Say magic. How from different 7 colors you got the white color, but it's true, no? So he proved that the white light comes into the rainbow that has 7 colors, and then when you combine this in the 7 colors in the disc of Newton and rotate those in high speed, you see white. No? So those are big contribution from this genius Isaac Newton. No?
And it's such a simple experiment.
Yes.
but you need to have the understanding first to be able even to try it.
Exactly. You have to have the understanding of that, no? And but again, the other thing about Principia Mathematica, I wanna finish with this thought, is if you have ever read that book, it start like the Greeks start, this famous Greek Euclides start his math. No, his math was remember that Euclides' math hasn't had change until the 18th or 19th century, when we had no Euclidean geometry. No? Newton's is the same. He started defining, okay, this is mass, this is velocity, this is distance. And with that definition, he ended up in gravity. So it's marvelous. If you have some time, read Principia. It's a wonderful.
Well, and as you said with Euclid, you know, it wasn't until recently that we moved beyond that with non-Euclidean geometry. But his geometry still it applies to most of the cases.
Yes.
The same with Newton.
Yeah.
You know, we are starting to, you know, there's scientists now that are working on, you know, what was the physics like at the Big Bang? What laws of physics do we use at the center of a black hole, where gravity is almost infinite? And so there are cases where we are looking at something that's different from what Newton discovered. But for the most part, as you said, we use Newton's equations to get to the moon.
Exactly.
And we're going to use Newton's equations to get to Mars as well, or anywhere else that we want to travel, we're going to use his equations.
Yes, definitely. So I think Newton is summarized one of the big brains in our modern era. No? When I start talking about the next one that we have today, and the next one is Bernoulli, and you know something about Bernoulli, he is from Switzerland, but Bernoulli has a family of physics and mathematicians. So there's Jacob Bernoulli, there's Daniel Bernoulli that has the Bernoulli principles in physics. So there's a series of Bernoulli's family, all geniuses. So Jacob Bernoulli is the most famous of the mathematicians, but there are others, Bernoullis. No, so that's why I think when you read your physics book, there's a lot of Bernoulli. Well, this guy is a genius. No, it's a family.
Oh, not just one Bernoulli.
No, there's not just one Bernoulli. There's a family of Bernoullis, of geniuses there. No, so but in this case we are going to talk about Jacob Bernoulli. No, but Jacob Bernoulli, it's born in Switzerland in 1665. No, and Bernoulli, he has again a lot of contributions. The first one is discovering the E number. So what is the E number? No, it's 2.7 something. I don't remember the number completely, but the idea, he was trying to grasp the concept of interest compound. No, and let's have a simple thing. No, for example, imagine that I'm going to a bank, and this bank is very generous bank. No, but they say, okay, you're going to give me $1. At the end of the year, I'm going to give you $1 more. So 100% interest in 1 year. So at the end of the year, you're going to get $2. No? So, well, no bank is going to do that. But let's imagine that there's a very generous bank that do that. Okay. So then you say, okay, that's nice. I like it. No. But what about, instead of giving me 100% in a year, you give me just 50% during the first 6 months and 50% during the next in the second half of the year. Well, the one say, yeah, we can do that. No, so you got $1, $1.50 by 6 months, and then instead of having 50 more, you have 125. So you got another portion more, and at the end you end with 225. Wow! So I'm not getting just $2. I'm going to get $2.25. And then you ask the question, okay, what about if instead of every 6 months, every month I receive just 1 of the 12 of interest,
1/12, yeah.
1/12. So that's how he reduced until, and that's important, he get into the, instead of every month, every day, every minute, every second. So how far it can go. No? Again, we have the concept of infinite here because, and Jacob Bernoulli can do this because that concept was very laid out for mathematicians that precede him. No? And then that's how he discovered the E number. No? E number is 2.7. I didn't put it in my notes here, but everybody knows the number E, no? The same as pi, which is a relationship among the circumference and the diameter. E is another big number in mathematics. No? Jacob Bernoulli, that's one of the things for the people that didn't know. He also studied theology. You know, his father was a pastor in a church in Switzerland, and he wants Jacob also to be a pastor, but Jacob, was so genius that he said, okay, I'm going to go with math, but he never left his belief. He didn't say, oh, because there's math, there's no God. He never said that. No. And we are talking about a genius like Jacob Bernoulli. Let me give you another example here. No, Bernoulli also have, so for the ones that study statistics, we have the principle of Bernoulli. No, so he also discovered many ways on doing calculation of probability. No, and how does he came that? No, he came this with an exercise of trying to get into what are the chances if I win given X random game. No, and that's how casinos expect their earnings. No? Because they know that even when they cannot predict a single movement, they know that at the end the probability of winning against somebody that comes, it's X.
Yeah.
So they calculate that and they put that as a chance of them having their earnings. No,
and it works on any one game being random.
Yes.
That over time,
yes,
they're gonna.
They're
They
gonna
say
win.
the house always wins.
Yes, they say the house always wins. But that's because the studies and there's a lot of work that he did in ars conjundanti. That's the name of the book that he has. No, but he studied a lot of probabilistic from the mathematical view on what are the chances if. No, and we got the permutations, the combinations, and etc. Those things that not only applies to to games in a casino, but also it applies in nature, that we will see that furthermore when we do this series on physics. No, so remember we got induction from Pascal, and now we have a more understanding on what are the chances in the future of happening this due to these events, and that's because of Bernoulli. No, and this is how right now we also have these applications in economics, no, in finance, and that's how also some scientists expect results in advance.
Yeah, no? You look at the basis of a blind study now. There's these principles are part of that.
Yes.
If you're anyone that does a scientific study trying to prove if something happens or not, or the likelihood of something to happen,
Yeah.
right? It's going to use these principles.
And also by this is in a couple of years more after Bernoulli, but we are going to use these principles when we talk about the law of gases and the probability of one particle in one state of energy. No, so we and when we talk about physicals in particles, we talk about in what state of energy those particles are. Since we don't see the particle, we assume in what probable state they will have.
Yeah.
And that's we apply a lot of Bernoulli principle there. That's high physics, and it's really hard to understand. Trying to give my best here.
Yeah. Well, we desire to understand many things, but we do not have the PhDs
yes, exactly.
to truly understand many things.
Exactly. One of the things that Seth and I were talking prior to this filming is, we are starting to get into the era that some things, but some things that's you really have to study
right
in order to get the grasp on that.
Well, yeah, and the as you said many times before, one of the things that's amazing about a lot of the early mathematicians is that we're still using their equations today. Yes. But the early mathematicians were at the point, the things that we're studying are the things that we learn in middle school and in high school.
Yes.
And as you said, we're getting to the point now where the things that that Bernoulli and other mathematicians in this era, these are things that people study in college, university, in their master's and even in their PhD work.
Exactly.
So we don't have
that background,
that level of understanding of a lot of these principles.
Definitely not. So want to jump to another genius of the modern era, which is Euler. No, Euler also was born in Switzerland. Euler was one of the students of one of the Bernoullis, not Jacob, but and I think his brother or something, because his brother, Jacob's brother, was also a mathematician. Well, the family,
it's a smart family.
Yes, very smart family. But Euler there, he born in Switzerland in 1707. No, and he was also a devout Christian. No, who believed that the Bible was the inspiration of the Word of God. No, and remember, Switzerland by this time was one of the I think it's Calvinism, if I'm not correct, but
it was Protestant at
this
point,
one of the Protestant denomination. That's true. He was a devout Catholic, and but let's talk about math, about Euler now. So we were talking about number E discovered by Bernoulli. Euler gives E to the most important case that is used up to date. When we talk about E, he understands that this is also, besides the number, it's a base of a function of logarithms it is the only function that has this characteristic. So you have the e to the elevate to the x, no? So e elevate to the x, you imagine the number like that. At any point, the graph behind that curve, it's also e to the elevate to the x. So the integral of e elevate to the x is e to the x, no? And also, if you put the slope at any point, the slope, it's also e elevate to the x. It's the only function that if you integrate that function or you derive that function, derivate that function, is the same function. It doesn't change.
Wow.
And that function, because of that property, it's widely used in math, in physics, and in many other applications right now. No? So, and we have to give this study to Leonard Euler. No, Leonard Euler, and he demonstrated. I don't know how he demonstrated. He's so smart, but he demonstrated that each one of these functions, because of its nature, has unique properties, and that can help in many other applications, in real life applications. The other thing is that he combined E, pi, and the I for imaginary number into the most beautiful equation. No, it's E elevated to I pi plus 1 equals 0. So this has been selected as the most beautiful equation in mathematics. But you see how he is able to derive a mathematical truth when you combine imaginary numbers, you combine pi, you combine E, and the two numbers in nature that everybody understands since they are little, the number 1 and the number 0. That means there's nothing here. So that's one of his biggest contributions, I would say.
That points to, as you said before, that points to an order.
Yes.
That is simple and beautiful.
And we are putting here imaginary numbers into math that even up to this moment, we weren't able to use until, let's say, the beginning of the 20th century, when we want something to explain movements in quantum mechanics. No? So we are talking about Euler. We are talking about 1800. No? And Euler is setting the foundations on how to combine. Of course, E will be used almost immediately, but how to combine the imaginary numbers with this beautiful E number in the functions of E, in order to give the math foundations to quantum mechanics.
Yeah. Well, yeah, and as we said before, that the beautiful thing about math is that you can discover something in math that makes sense.
Exactly.
Theoretically, that, as you said, will not be used, but will be used at some point to explain something in the physical sciences, because the number of times that a physicist has tried to explain something in physics and then discovers an old equation, like, wait a second, that looks familiar to something I'm looking at. Why have I tried to apply that to the situation? It's like, oh my goodness, it fits.
Yes.
That someone like Euler would find an equation just because it makes sense.
Yes.
Just because it makes mathematical sense and can be proved mathematically, that at some point in the future will prove that there's an application in physical sciences.
And that reminds me, our initial question, is math real? No?
Yeah.
Is math real? I mean, we may not touch it, but it's a reality in the world of the ideas, the world that it's immutable, that doesn't corrupt. No? And this, what Euler did, is just a proof of that. No? It's just a proof of that.
Well, and going all the way back to Plato's cave, it's hard to imagine. We talk about, you have a table here, we have a table over there, physical tables that are built and that fall apart, but you have the idea of a table.
Yes.
Well, it's hard to imagine what the idea of a table is.
Yes.
Right. But when you're talking about math, you can say, well, I have an equation. Well, that equation is an idea, right?
Yes.
It's you don't have a physical equation that you can hold on to. So you have an idea of an equation. Well, that equation can be applied to the physical world. When you're studying science, you say, okay, well, this equation explains this process. And so you have an idea, something that only exists in your mind, that then you can say, okay, this makes sense because of this idea. And you can say, well, maybe someone just made that up because it makes sense. Well, maybe these ideas are actually out there to be, discovered, so that we can then take them and then make sense of the world because of them.
I'm definitely with you on that one, because we are looking at the history of math, because it's the tools that math give us will help us probably later to understand, as you said, the physical world. No? So Euler made many other contributions. Now we have he introduces the current notation that mathematics is using. For example, the S for the integrate, the symbol for the addition, but the addition of series. No, the slice E Greek. Then we got also the letter pi to refer to that number. No, he discovered the graph theory that is going to be very used in topology, which we are using that science currently, and complex numbers. Okay, not only he introduces the notion of functions, but also he introduces complex number into math, as we have seen. No? I think Euler, I have read that many mathematicians after Euler, they always, get their theory done, but they also quote, to understand it, please refer to Euler's principles. So he set somehow the foundation for further math that mathematicians after him start using, but so good foundations, no? So good notions of functions, so good notions of imaginary numbers that many mathematicians after took him as their cornerstone to build on top of. No?
Probably even say, the modern era of computer science looks back to him for a lot of his principles on how to logically structure code. We keep going back to this concept, but it is amazing that you have these mathematicians that are they just want to understand truth. They want to understand the structure of the universe. They want to understand, how things logically work, and we go back to all of them as a basis for what we're doing now in the modern world.
So I think that our next series is going to take us math unto this point, but I love what, with these four mathematicians, we are starting to understand, that there's no divorce among math and God, no? And what's more, how is the true nature to look at math? No? Is to understand a reality that is beyond us. And what I like about math is, mathematical equations are not in the physical world. They can be applied in the physical world. But there is a very good example in math that, not every true is a true in the physical world.
So in 1794, there's an artist, William Blake, and he made this painting that I love. It's an image of God with a compass. And I know I've had in my life this idea of God as, this old man in a robe, and he's just given us all these rules. And the main purpose of God is to say, do this and don't do that. And I think that's a very common view of God, that he is just there to give us morality, and especially the list of all the things you're not supposed to do. But this image of God, this painting, I love it because it sees God with a compass, and it shows God as the author of all truth, including mathematical truth, including the structure of the universe. And at some point, I want to do a series on seeing God through the eyes of science fiction. But as we've kind of alluded to a few times in this episode, when you look at the structure of the universe, when you look at the logic of math, when you look at how well everything fits together, how everything works together, and how it all makes sense, like we've said before, the order of the universe, you get an image of God that is intelligent and is creative, and the imagination of God to create a universe that is so complex and so beautiful and so orderly, that this image of God with a compass, that he's not just this guy up there that says, here's what you can't do. He created the universe because he wanted to create something beautiful and orderly for us.
Yes.
Right.
Completely agree with that.
Right.
One of the things that amaze me when I think about, many people say, well, we are just a point in the universe, but I see it the other way. He created a whole beautiful universe just for us to enjoy it and to discover it.
Yeah, you look at authors like Lewis that want to continue to discover and imagine the universe and what it can hold. We understand such a small part of what the universe is like.
Yeah.
And we're sitting in this tiny little corner of this big galaxy that's only one of thousands of galaxies. Who knows what else out there we're going to discover? But as we said, that every time we discover something new, we see how it all fits together, and we see how it is all ordered, and it all makes sense, and we can continue to learn more about it.
Yes. Yeah. And we are going to continue to learn more about this in our next episode.
Yeah. Well, thank you for joining us for this other episode, this next episode of Nerding Out, and I hope you have been nerding out with us. As you see, this is something that we just love learning about and talking about. This is not just something that we're sitting here and recording. This is a kind of conversation we have all the time, and I just encourage you to continue to dive deeper into not just science, but philosophy. Continue to, my encouragement to you is to continue to learn more about the world around us and how it all fits together. And part of that, as we talked about Pascal's wager. If you study science, or if you study math, if that's something that you love, but you have this thought in your mind, it's like, well, God doesn't fit in this picture. I want to encourage you to read something like Pascal's Pensees. Read Chesterton or Lewis. These are intelligent people who also write about God. I want to encourage you to allow space for a God that fits into this world. Not even, I wouldn't say fits into this world, but a God that is big enough to be able to create this world and create the order that just allow for the possibility that there is an intelligence out there that has been able to create everything and give order to everything. And we'll look into this when we start talking about philosophy. But as Aquinas says, God is not a being in the universe, but God is being itself. And all being comes from God. So I just encourage you to allow for the possibility of a God, and just go from there. And as you said, seek him, and he will be found. But you first have to start with the possibility that he exists.
Yep.
So we hope you join us again next time in our continuing discussion on math and further. I will encourage you again to check out thatnerdycatholic.com, especially thatnerdycatholic.com/merch. You can get our mugs, t-shirts, and other things, and help support this channel. Please subscribe to our channel, share these videos with your friends, and leave any comments, questions in the comments below. And anything we might have made a mistake on, let us know. And we want to continue to learn ourselves, even from our own mistakes. But please come back. Looking forward to seeing you next time. Bye.
Bye-bye.
System shut down.